David, hi. Thanks for joining me on Architect tomorrow.
Thanks for having me, Oliver.
And so let's kick off with giving everyone a bit of a background on Leafcloud. How did that get started?
I used to work at a startup called Nerdalized in Delft, and Nerdalized did what we do, very similar in setup, trying to build truly green cloud.
Yeah.
They put it in much smaller locations, so like 800, 1200 watts per site for apartments, individual apartments, and that meant that it had to be silent, deliver 60°C heat,
right,
and secure in people's homes. Mm. So they built their own hardware, they had their own network booting system, a whole complexity.
Yeah.
So they made it way too complex. They had a big team and hardly any recurring turnover.
Right.
When the goal itself, building sustainable cloud, when you want to get to 100% in one go, that's too complex. So they failed, and I was already a bit saying that we should simplify and maybe do bigger installations.
Okay.
And when they went bankrupt, a couple of months later, I was called by an investor that bought what was left.
Yeah.
And he said, multiple people said I should talk to you.
Okay.
And I had the chance to reboot it, and I thought to myself, like, do I want to do this? And I was like, yeah, I want to do this because I don't think that it's finished.
Right.
We've tried it, but we just didn't succeed in execution, not per se an idea, because the idea is still very, very good. So I got the chance to reboot it and took all the assumptions they did, simplified everything, threw away the assumptions that were incorrect.
And so what is Leafcloud now trying to achieve then versus the sort of other stuff that was too niche? You're going for something more general purpose?
The basic concept is truly green cloud.
Okay.
So people can buy virtual machines or GPUs for AI from servers that use the waste heat. Right. That's the core of what we're trying to do. So this is larger installations. Something like between 20 and 40 kilowatts per installation. Yeah. So large apartment complexes, swimming pools, hotels, elderly homes, those kind of places that need heat 24/7.
Yeah.
And then, we've simplified in the sense that we no longer develop our own hardware. We use very popular open source projects to make sure we don't have to develop everything in-house. Yeah. So really keep things very focused to the core of the business, which is delivering truly green cloud services. Yeah.
And so where does the heat recovery happen? Because I guess I've spoken to quite a few people about heat reuse from technology. Are you essentially sort of incepting sort of the coolant system somewhere and then linking it to the kind of community heating system? Help people understand how you're taking, I suppose, the waste heat from compute and turning that into heating for
but basically we have to sort of understand what is the issue, right? The issue is that a data center is a highly centralized power place where all the servers stand. Yeah. And then because they're highly centralized, they need to be cooled using air conditioning. Yeah. Throw all the heat away, right? By not having them centralized, if you need to extract the heat from that data center, you need to work it up to a transportable temperature, right? So you need 90 degrees Celsius water coming out. Yeah. Well, servers deliver 35 C air, right? You can't store 35 C air, you can't transport it. So it's a massive issue inside a data center, and it's not cost effective to extract it. So what we do is we put them in the location itself, and there it only needs to go from 30, 40 C air to 60 C water. Okay. Now this can be done with any off-the-shelf heat pump or even with direct chip cooling. You can do it directly from the CPUs, deliver that temperatures. So it's much simpler and much more cost effective to do it.
So do it a sort of a medium scale size, close enough to where the heat demand is, that you can make it work. Because when I was at Data Center World a few weeks ago, there was talk of trying to kind of get the coolant network, I suppose, up to a much higher temperature you could then transport, but that feels far more complicated than essentially what you're doing then, which is more localized.
And also it's basically so let's say you want to run a server somewhere, right? You want to run a machine for your application. If you put them in a data center, you have to pay the data center,
Yeah.
and then the data center has to pay to extract the heat and to transport the heat to somewhere.
Mm-hmm.
So it's a cost add on top of an already quite expensive business.
Right. Yeah.
Whereas our locations, they exist. The cables in the ground, or the fiber exists, the power exists, the cooling of our servers or the heating of the building exists. So with us, it costs less money to put servers where heat is needed than it does to put them in a data center.
So essentially it's a cost argument because you're getting access to space that you perhaps wouldn't otherwise better tap into.
Yeah.
I
literally pay my server space rent with waste heat.
It's kind of like barter. It's kind of like
it's a barter.
Okay. No, that's Because when I was speaking to others about this, the concept is it just drives down cost because the cost you have of having a separate facility for the data center, some of those costs go away, and so it's okay. No, so I think
this is something we discovered along the way. We wanted to reuse waste heat, and then we realized, hey, this is actually much more cost effective as well, and that's where you of course have a good business model.
Puts you into city locations that otherwise are hard to get into.
Completely possible.
So like particularly like for example in Amsterdam, if you wanted to put a data center in Amsterdam, it's like probably near or impossible.
There's a data center stop.
Right.
Yeah. So they've literally said no more. And if you want to build one, you have to reuse all the waste heat. Yeah. And then all the big data center operators say, well, that's really expensive.
So and then you need to break up that data center into smaller, more localized parts, which is effectively what we do. Okay. No, that makes sense. So let's talk a little bit more about sustainability in general and tech sustainability in general. And one of the things that comes up a lot in my conversations is metrics, right? And when we were preparing for this conversation just now, you and I started getting into a really interesting conversation around metrics. So, when I speak to our clients, they're often after, what's the CO2 saving, how much energy is going in, what's, all these numbers, because essentially they want a report. They kind of want a nice report they can give to shareholders and stakeholders. Where do you stand on sort of metrics? Is that where you started Leafcloud from? Like, let's make this as efficient by the numbers as possible, or what's your philosophy?
Well, it's starting a cloud provider is hard, right? Let's start with that. Reason why you never hear people saying, "I have a cloud startup." That's something people don't do because it's really expensive, it's really complicated. So anything you do that adds complexity to it is something you have to be very careful about.
Right.
Now, metrics are not only very hard because they require a lot of work and a lot of checks to get it accurate. Yeah. Preferably, if you want to get an enterprise to trust in it, you want to get it from a third party. Right. So you want to get some validation, universities involved. Right. So these things take long. Well, being a cloud startup, I don't have time, right? Yeah. So I tend to prefer to focus on the things that actually matter from an engineering perspective, like do things that are actually sustainable, right? And then once we're up and running and we're scaled out, we can start doing adding metrics back in. And that's sort of the reverse approach of the rest of the industry. The rest of the industry says, I'm going to put those metrics in first, and then I'm going to reduce, right? Because if I put those metrics in first, my baseline is really high, and then I can reduce properly. Right. I think that's the wrong priority. For me, I want to prioritize on doing things that from a ground level make sense in carbon, that you can calculate, that you can double check, that I can go to my old university professors and say, does this make sense to you, or how would you calculate this? And they would come down to the same
And I guess that makes sense for yourselves, because I guess you're very demonstrably putting compute in places where there's heat demand, right? Yeah. That's very different to a centralized data center that's like, rather opaque, black box, often very secure, quite secretive about how it's run. And I guess
basically these metrics are about how effective you throw away heat.
Well, this is the fascinating thing about PUE, right? Yeah. It seems like a perverse metric.
Yeah, it is. Like PUE 1 means you've thrown all the heat away. Congratulations. Like in my experience, that a lot of the IT cooling industry is about cooling, right? And a lot of the things that you think make sense for when you're fully doing a heat reuse operating model, really don't fit on top of that. Even things like ERF, for example, energy reuse factor, sort of acts like a data center is sort of the fans inside of a data center and all the cooling equipment inside of a data center are effective IT power use.
Okay.
Right, but that's still something that's needed to cool off the IT and then to deliver it.
Right. Let's unpack the PUE thing, because I think people won't necessarily understand that throwaway remark we made, right? Because the power use effectiveness thing is essentially how efficiently you're using electricity, and what it hides is the fact that if you don't use electricity for heat recovery, you look more efficient. This is my understanding, right?
Yeah, it goes a bit deeper than this. So let's deconstruct, right? Yeah. It's basically the total data center capacity, or power. No, the other way around. Yeah, total data center power divided by the total power needed for the IT.
Right.
First of all, there's no standard of what you put below the division.
Okay.
So if you add, for example, rack level fans or rear door heat exchangers, generally the fans inside of the rack are counted as useful IT power.
Right. Okay.
So they're on the bottom.
Well, it's a grey area, I suppose. Where do you draw that dividing line?
Yeah. Google has a really clearly defined way of saying it. Yeah. Amazon seems to put everything under the line that they can get away with.
Right.
So there's already a very vague description of
what is IT,
what is IT,
what is supporting.
Now, basically, it means is so. Okay, let's say your data center uses 1 megawatt and your servers use 500 kilowatts. Then your PUE is 1.5, right?
Yeah.
So,
that's
how it works, and that means for every 1 unit of compute, you throw away 1.5 unit of energy needed for cooling. That's what the metric says.
And I guess the way that many understand PUE gets so close to 1 is you're essentially using like water and other things, evaporative cooling and things that aren't using energy to kind of manage that heat.
Anyone who, and that's it, actually I've seen the government of Amsterdam, they had a PUE requirement of 1.1 without water usage effectiveness requirement.
Oh, right, okay.
So that means basically you're saying use tap water for cooling because then you'll hit our sustainability metric.
So I guess the lesson here is don't use PUE on its own, right? It needs to be in
combination with
other things. Otherwise, all you're doing is what you measure gets managed, right? And so the gaming of metrics is clearly a problem, but I guess people would like to see numbers, but I understand why I think the Leafcloud hasn't taken that direction. You're trying to do something real, which demonstrably is recovering heat. So in which case the metrics can come later, perhaps when it'd be a good, nice problem to have when you're looking at that.
Luckily enough, like most clients don't really ask for those things. Okay. They do trust us to do things in a proper way, and we've also shown locations to our clients to just show like this actual. We actually put those servers there where the heat is needed.
Yeah. So the next one I've got for you is, of course you can't have a conversation right now without mentioning AI and the exponential growth, particularly, and that's what ultimately I guess what's driving data center demand right now is the demand for AI. Where is your head on kind of because I guess there is two polar extremes I'm seeing at the moment. Like there's this techno-optimist sort of abundance mindset, like almost behaving like we've already invented fusion and we have limitless power. And on the other hand, I have like the frugalists who are like and the degrowth people who are saying, oh, we should go and switch everything off, almost like the Luddites going and smashing the looms, going and smashing the data centers. Where is your head on like kind of, is there a pragmatic sort of way forward?
I think there is.
Yeah.
So energy needed for hot tap water worldwide is massive.
Okay.
If you take the currently installed data center capacity in the Netherlands, in the Netherlands, it's about 6% of all electricity goes to data centers.
6 or 6?
Yeah, 6%. So that's quite high.
Yeah,
that's one of the highest in the world. Ireland is like 21%. It's insane. So if you take the currently installed IT capacity, so it's not what they actually use; it's what they have reserved in power.
Okay.
And you transport all of that into waste heat, you'd give 50% of all showers in the Netherlands.
Interesting. Okay.
And that's not even touching space heating in winters, right?
Yeah.
Which lasts for months and months and months here. So if you'd put all servers where heat is needed, there is still a lot of space for growth.
Yeah. Okay.
If you're going to put them all in data centers, then I'm on the defeatist part and say like, no, let's not do that. Let's not. What McKinsey had a paper a couple of weeks ago. They expect triple the power use of IT over the next 10 years here in Europe.
Yeah, it's quite a debated figure, isn't it? I suppose a lot of it depends on whether the AI trends we're seeing at the moment kind of are sustainable in a financial sense, rather than, you know. And I wrote something last year that basically, I think it's almost undeniable that we're living in a bubble, but there is a degree of the world has changed. Yeah. Like everyone is now using AI. I mean, like literally preparing for this, I was showing you my sort of AI assisted homework, right, for this conversation. So I think that the world has changed, but whether fundamentally this sort of pathway to AGI, which, you know, a lot of the tech companies are talking about, is, you know, when the air comes out of that bubble, and sort of what degree, things get corrected, I suppose, is going to be interesting. But I think growth is undeniable for sure.
Yeah, but it's also like these kind of predictions. There's so many unknowns, you know, you can calculate it with sort of what NVIDIA has done over the past 5 years in efficiency gains, and then you can extrapolate the efficiency gains over the next years and say, okay, AI growth like this, and efficiency gain of NVIDIA is that means your energy use is going to be there in 10 years. But then you're skipping all the stuff like, you know, people working on ASICs for transformers and the dedicated chips that people are building, and the guys at Grok with a Q, not the one from X, building their own chips that are way more efficient for inferencing than anything else.
I mean, it does feel like, you know, what we had with Bitcoin mining was obviously GPUs were used in the early days, and then all of a sudden someone realised that ASICs were far more efficient, and then GPU values sort of. So I think training. I
think it was like 50 million on the first round for these guys working on ASICs for transformers. So there's already insane money going there.
I mean, it's not surprising, right? I mean, like if you can crack more efficient inference, then that's a significant business, right? So I guess it's an interesting time at the moment. But I guess for those that are sort of trying to pragmatically think about how to make their technology use more sustainable, what would be your sort of general advice to folks at the moment?
This is an industry that always chases Formula One cars. Right? this is the everyone wants the fastest NVIDIA machine and the fastest Intel and AMD chips, and the largest large language models with the 720 billion parameters. Everybody loves this stuff.
Bigger is better. Right?
Bigger is better, and I think we tend to forget that Formula One car is a horrible car to drive from A to B with.
Not really practical for the kids.
It's not really practical. So sometimes a scooter is just faster, right? Or a pickup truck.
Yeah. Or in the Netherlands, a bicycle.
That's a real efficient one. And I think in the IT industry, like stuff like small language models are jumping by leaps that even the large language models can't even touch. The same thing goes for, you know, stuff like there was a metric the other day, like most Kubernetes clusters are like below 40% use or something, insanely over efficient, and in Kubernetes we see this quite a lot actually.
So effectively fight against the sort of desire to over-engineer and over-provision.
Try to simplify, try to make things more effective, more efficient, and a lot of, I think the software world doesn't connect to the hardware world well enough in a lot of ways.
It's a bit too
there's
abstract,
lots of CPU features that go completely unused, where you can use compiler flags for using the vector extensions of CPUs that almost no one uses all these features. And they actually make a big difference.
What do you do actually engineering?
Do the actual work in making something a bit more optimized.
I guess there is a trend though, isn't there, towards, I suppose, abstracting away from the hardware and just sort of simplifying, if I can even say the word, and kind of these layers. It does concern me that each layer we add, it abstracts the engineer or developer away from the reality of the hardware.
It is to like hardware is pretty hard, right? That's the entire point. But to a hardware guy, it sometimes can be very painful. Like stuff like certain storage standards that are like, it's nigh impossible to get the NVMe speeds of one NVMe on a storage cluster, right? And even though you're using tens of these NVMEs, just one of them would have been faster if you just use the hardware and not the software-defined storage layer on top, and not the Longhorn and not the Ceph and all of these software-defined storage layers. That's really and I'm beating against my own horse here because this is something we offer, but the hardware side of it, does tend to be underutilized. Yeah.
Well, that leads on, I suppose, nicely to talking about the sort of utilization. If folks are thinking about using a Leafcloud, how hard is it, I suppose, for them to sort of transition from their use of AWS and Azure to, say, a Leafcloud?
Technically, it's not that hard, right? It really depends on how much of those managed services and proprietary services from Gugamasoft, as I call them, you want to use, or you do use. If you tend to focus on the open source standards and are a bit more multi-cloud inclined and use infrastructure as code, then it's fairly simple. So we've had clients that took a couple of hours to move some Kubernetes endpoints to us, and then the workload was running. We've had clients that it took 2 years to get an AI server started. So it really depends on the organization as well, in terms of how much security questions are you going to have. We tend to find that the sort of 2 to 200 people scale companies that are developer led, so the DevOps guys choose where their cloud lands, and there's no really complex CIO and at big enterprises tends to be really complex to add a new cloud provider. At smaller companies it tends to be simpler, and we can help.
And I guess your smaller company is probably deploying onto Kubernetes and sort of perhaps less coupled to a particular flavor of cloud managed services, as you're saying, because it's an interesting trade-off, and it's one we've touched on the podcast before, is how do you get the best out of cloud without going to native on the sort of cloud features. And this is another example of where actually but then this is almost in tension though with what we were talking about earlier, which is like leveraging the capabilities of the platform. So it's a tricky trade-off, isn't it? It's like, how much do you take advantage of that underlying platform versus
and we're based on OpenStack, so there's tons of documentation out there to get you started and to help out. So in that sense, it's fairly simple for the DevOps guys, but for the people that fear a lot of things. And just to be very clear, if you want to run a virtual machine inside of a data center, you totally can. It's just that we offer the option to run it where the heat is needed as well.
That's interesting.
So there is no, in terms of security, you can do it like that. But you can also run it where the heat is needed. But even in that case, it's secure. So how that works is your VM boots from a hard drive in the data center, but it runs over an encrypted line that is like 5 to 10 kilometers long. So it's like a dark fiber line to the location. So your line is encrypted, your memory on the location is encrypted, and the boot drive on the location is encrypted. So if someone would steal the server out of the rack there, they still don't have anything if your VM would fail on that location, because it's not a data center. We reboot your virtual machine within a couple of minutes somewhere else.
Interesting. Because I was going to ask if you're leveraging like confidential computing or anything, but it sounds like you're just using fairly standard encryption, which makes sense. So for those that don't know, if you go into an average cloud hyperscaler data center and just pull out a drive or pull out a blade, again, it's going to be fairly useless, right? Because it's just a shard of a system.
You don't even know where your VM runs. I don't think anybody does. No. But this is obscurity. We can't talk about that.
So, where do you see the future of cloud, in particular sort of sustainable cloud hosting, going? Do you think the hyperscalers have any ability to sort of become more sustainable and use heat recovery? I mean, it sounds like there are some inherent challenges in their operating model, right?
I really hope so, and I do think that there are extremely smart people at the big tech companies that really have their heart and minds in a good place. So I don't want to bash them from that point of view. But if you look at the overall sort of what they're trying to do, then my point of view is this, right? Their goal of all the big tech companies is they say we want to be neutral or negative by 2030, 2040. So their aim is down. However, their current track record is up. It's 25% per year for Microsoft. It's about 20% per year for Google. And we don't know what it is for Amazon because they hide their numbers so well. So their trajectory is just the other way around. They
and it's getting harder and harder as the sort of AI boom increases, right?
So currently, it's an industry that's growing 20-30% compound annual growth rate. In my point of view, when you have an accelerating oil tanker, it tends to be very hard to steer those. So no upper management at AWS is going to say, guys, we're going to do things completely different right now.
But I guess it's not impossible to consider they might start thinking about more of an edge business to complement their data center hyperscale. I mean,
they already do, right? For a large part, they all have this sort of on-prem solutions. But the focus is like in offices. If you really want to optimize the hell out of it, you might get 50% waste heat reuse in an office. But the weekends and the evenings and the lack of tap water use tends to so offices are pretty pointless actually.
That's interesting. I hadn't considered that, of course, unless you've got a location that's being used 7 days a week, which most aren't.
No.
Your heat recovery is only sort of part.
And then so we heat up tap water because tap water is not seasonally bound and it's worldwide in terms of use. It's very hard to do tap water in offices as well. So you're seasonally bound and you have weekends and you don't have evenings, so it's very hard to reuse.
So that's why it needs to be more residential.
Elderly homes and care homes are by far the best. Because they have super constant heat requirements.
No, that's fascinating. So David, if folks are interested in Leafcloud and want to know more, where should they go? What should they do?
Leaf.cloud.
Hit
the sign up button. And attach a payment method, and you're golden.
Very good. Well, Dave, thanks very much for having me in. And this facility is like the former Shell building you were saying, right? It's fascinating. I might try and do a few shots before I leave because it's quite a curious sort of place.
It's a funny place with a long history. And Shell is still down the street here, actually, with the massive offices. But this is no longer used by them. So this was squatted for a while, and then there was lots of illegal squatting parties here, which I didn't host. And then at some point, stuff went wrong here, and then the government made it sort of a playground for cool companies
to regenerate,
to start something.
Very good.
So it's a semi-government run location now.
Excellent. Well, look, thanks very much for your time.
Thanks for having me.
Great. Thanks.